January 2005, and Asia struggles to clear up after the Boxing Day tsunami and come to terms with the appalling destruction that claimed the lives of over 160,000 men, women, and children. Tragically, this was not a one-off event. These catastrophes have happened before and will certainly happen again. 122 years ago, another natural disaster struck in the same geologically active region of Indonesia. This disaster was not caused by an undersea earthquake of the kind that created December's tsunami, but by the volcano Krakatoa. This film is the story of that eruption, but it is also an account of the first tentative steps towards understanding the terrible power of Earth's natural forces. In the early morning of the 20th of May, 1883, a group of fishermen visiting the island of Krakatoa witnessed the beginning of a massive volcanic eruption. Indonesia was about to suffer a natural disaster that would result in a colossal loss of life. Several months later, Krakatoa would blow itself out of existence, with an explosion the equivalent of 150 million tons of TNT. It was so loud that the sound of the detonation was heard over a twelfth of the Earth's surface. The shock waves reverberated around the entire planet.
These vibrations are airborne. It's not coming through the ground. It's not an earthquake.
This explosion also caused giant tsunami, the largest of them twice the height of those of 2004.
Dear God! Take her into the wave now!
These enormous waves wiped out 165 Indonesian towns and villages, killing over 36,000 people. Within hours, news of the disaster was transmitted around the globe, and scientists of the time struggled to comprehend the geological forces that caused the tragedy. This film uses the true stories of survivors from their accounts and diaries to piece together what happened in the months leading up to the most famous eruption of all time. In 1883, Ketimbang, on the southern tip of Sumatra, was a rural outpost of the Dutch colonial empire. There seemed little that would disturb the daily life of this heavily populated coastal village. It was situated just 23 miles north of the island of Krakatoa. Sumbi, a local girl, was starting her first day as a nanny for the wife of the Dutch regional official. As one of the only European women in the area, Mrs. Berink could not be seen to socialize with the locals, and she remained isolated and lonely. Her diaries provide one of the best accounts of the eruption.
His name is Yanni.
It's very beautiful.
You may play with him for a little.
Saya akan menulis surat kepada Tuan Residen atas perhatian Bapak. Semua pergi sekarang. Saya harus ketemu banyak orang sore ini.
Willem Berink, the husband of Mrs. Berink, was the controller of Ketimbang and responsible for enforcing colonial law and order. Each morning, he will hold a clinic for the administration of the affairs of the local people. Berink was well versed in a number of skills, including Islamic law, local languages, and rudimentary geology. Indonesia is a group of thousands of islands in Southeast Asia. The largest islands in this archipelago are Java and Sumatra. The Berinks lived at the southern tip of Sumatra in Ketimbang, just 23 miles north of Krakatoa. Krakatoa was surrounded by the waters of a busy shipping lane, known as the Sunda Strait. Within sight of Krakatoa were the low-lying and densely populated coastlines of West Java and southern Sumatra. In the coming months, its unique position would prove deadly. To navigate these waters, lighthouses had been erected along the west coast of Java. The closest to Krakatoa was Fourth Point Lighthouse at Anya. As its recently appointed keeper, Temang would be one of the first to witness the beginning of the eruption. He was married with a son. Passing even closer to Krakatoa was the Dutch government steamer, the Governor-General Loudon, that regularly crossed the Sunda Strait.
Gentlemen.
The ship was under the command of ex-Dutch naval officer Captain T.H. Lindeman.
Spick and span. You know how I like it.
For the captain and crew, the volcano was a familiar landmark that sat quietly on the horizon. Krakatoa had been dormant for over 200 years, but forces deep beneath the Earth's surface were about to wake this sleeping volcano. By March 1883, subtle warning signs of the danger that lurked below the volcano were felt on the surface as faint tremors, undetectable to human senses.
What's the matter with you, eh? What is it? Get yourself set about, eh? Shh. There now.
"83 miles east of Krakatoa, on the north coast of Java, was the busy port of Batavia. Batavia, known today as Jakarta, was the capital of the Dutch East Indies and a hub for ships plying the spice routes. Since the 17th century, Holland had been a dominant force in the commerce of the Far East. Oriental spices and raw materials were highly prized, and in the name of profit, the Dutch ruthlessly exploited Indonesia, exporting everything from gold, rubber, and sugar to cinnamon, pepper, and timber. Large numbers of trading ships would travel back and forth to Europe. Each one would sail through the Sunda Strait and pass Krakatoa. In 1883, Dr. van der Stok was the director of the Magnetic and Meteorological Observatory in Batavia. His duty was to report signs of seismic activity directly to the authorities. As the wife of a Dutch official, life in Batavia for Mrs. van der Stok was restricted by a rigid social structure. Each day drifted by with little to occupy her, except a burning desire to return home to Holland. Also stationed in Batavia was Sherman, an energetic young geologist. Sherman would have had a good understanding of volcanology, but in 1883, the science was still in its infancy. Dr. van der Stok was responsible for monitoring seismic activity throughout Indonesia. As a scientist, he wrestled with important questions of how the geological activity of an area could be understood and whether potential disasters could be predicted.
Sherman,
Director?
have you come to return my books?
Oh, I've not quite finished with them yet.
You know the 11th commandment?
I find 10 hard enough.
All books borrowed must be returned on pain of hellfire.
Is God a librarian?
Well, if he was, you'd be struck down dead where you stand.
I was wondering if you had anything on animal behavior. You know, there's an old Japanese story about catfish. They behave oddly just prior to an earthquake.
Really?
Well, you've seen for yourself how dogs and domestic animals become disorientated just before a thunderstorm.
I don't believe I have anything on the subject.
That only goes to show there's a book to be written on it. Just think, animal behavior could be used to predict the weather, even earthquakes. I've heard that the Chinese use grasshoppers. If we could relate the results of your instruments with observed changes in animal behavior,
Sherman,
then...
enough. This is hardly science.
Of course it is science. Everything's science. I should go get a dog.
And don't forget my books.
Near Ketimbang, on the densely populated coastline of southern Sumatra, lived fisherman and village elder Ajib. Ajib was one of the local spiritual leaders who acted as guardian to traditional Indonesian beliefs, passed from generation to generation.
Aya nu ngaranna jin alije. Alije. Eta setan hantu di Gunung Krakatau, gunung. Kamu mun manehna keur mabok, manehna beuki nguntahkeun seuneu di golongan irungna begitu.
Although regarded as pure superstition by the Dutch, the local belief was that the volcano Krakatoa was home to the fearsome fire-breathing god Oran Alige. When Krakatoa had erupted in the past, it was because Oran Alige was angry, and Ajip was convinced that one day soon the volcano would erupt again. Pressure building deep beneath Krakatoa was beginning to make itself felt on the surface. Magma from deep inside the earth was rising, and the volcanic island, only 23 miles out to sea, was preparing to erupt once more. The eruption of Krakatoa, over 120 years ago, has become a landmark in our understanding of how volcanoes affect our planet. Mike Rampino is professor of geology at New York University. His research has been instrumental in discovering why Krakatoa erupted with such force. He's returning to Indonesia for the first time in 26 years.
The 1883 eruption of Krakatoa is one of the most important eruptions in the history of science. I think probably the most important eruption in terms of history of volcanology. For the first time, a large explosive volcanic eruption took place when there were enough observers spread around the world, on land, on ships at sea, to really get a global synoptic picture of what happens when a large volcanic eruption takes place.
Krakatoa's devastation was not wreaked by the eruption itself, but like the disaster of 2004, the massive death toll was caused by tsunami. Volcanologist and writer Bill Maguire from University College London is an expert in tsunami, but those generated by Krakatoa in 1883 are of particular interest to him.
At the time, nobody would have understood that a volcano, which is at the closest 25 to 30 miles to Java, would have posed any problems at all. Even though the ash was falling and could see the red glow, I don't think anybody thought it was going to come and get them, because they didn't know about tsunami, certainly as a result of a volcanic eruption.
To understand what Krakatoa was like in 1883, Mike Rampino has traveled to the volcanic national park of Tengah Bromo in East Java. Indonesia is the most volcanically active region on the planet. The country contains 17% of the world's active volcanoes. The view at dawn from Mount Penanjakan shows several of these volcanoes within a few miles of each other. This is the jewel of Indonesia, but it's a beauty born from brute force.
There's a kind of rule in geology that the more beautiful the landscape, the more dynamic the processes are that create those landscapes. And volcanism is one of the most dynamic processes that exists on the planet. And so we see these beautiful volcanoes, these craters with steam and ash coming out, and we think how beautiful, how dramatic, how gorgeous. But it's what's underlying this, what's going on underneath the ground, inside the earth, that makes this such a dangerous situation.
The reason why Indonesia has so many volcanoes and earthquakes is due to the country's geographical position. The archipelago that starts in northern Sumatra stretches over 3,000 miles south. It has been created by the forces where two of the tectonic plates that make up the Earth's surface meet. The ocean floor of the Indo-Australian plate and the Asian landmass of the Burmese continental plate are in collision. As they push against each other, the heavier ocean floor is forced underneath the lighter continental rock.
When these plates or slabs come together, one pushes its way down back into the interior of the Earth. That process is called subduction. And as that crust is pushed down into the hot interior of the Earth, the rock melts. And some of that melted rock finds its way back up to the surface through fissures and cracks and erupts at the surface to form volcanic eruptions.
Indonesia's volcanoes lie directly above this subduction zone, but the scale of Krakatoa's eruption was boosted by one more key factor. Between Java and Sumatra, the subduction zone makes a pronounced change in direction. This bend distorts the Earth's crust, creating large fissures and cracks right beneath Krakatoa.
And that is a place where the bending of the subduction zone leads to tension and stresses and faults along which magma can rise up from the interior and find its way to the surface to create volcanic eruptions of enormous size.
From the archives, volcanologists have pieced together Krakatoa's eruptive history. In 416 AD, an ancient Krakatoa destroyed itself in a massive explosion. Over the next 1,200 years, regular minor eruptions rebuilt the volcano. These small eruptions helped release the pressure created by the enormous geological forces beneath the island. But over time, a plug of thick, viscous magma formed in Krakatoa's throat, preventing the gases and magma from escaping to the surface. The eruptions ceased, and by 1883, Krakatoa was a time bomb, waiting to explode.
Well, that all seems in order. Thank you. Pergi. Anna.
I thought we might take a walk this afternoon.
I'm rather busy.
I know. But I can hardly wait until you're not busy, can I? Then I would wait forever.
Well, perhaps tomorrow, hmm?
You promise?
Very well. Oh, no, I can't. I have a report to write. I have to get it off to Batavia tomorrow.
And if your report is one day late, will it matter?
Why can't you accept that I have a job to do?
With the strength of the tremors increasing, it fell to Bering as controller to report them to his superiors in Batavia. But having no clue where the tremors were coming from or what was causing them, he was unaware of the danger that lay only 23 miles out to sea. Just before midnight on the 9th of May, 1883, intense pressure building deep beneath the Earth's crust broke through the line of weakness directly below Krakatoa. Magma, moving towards the surface, split the crust apart, creating a large tremor. That night, Tamang, the lighthouse keeper, saw the momentary flattening of the waters of the Sunda Strait. The force needed to freeze the ocean is almost beyond imagination. This was the first documented warning sign of the beginning of Krakatoa's 1883 eruption. "11 days after the tremor at the lighthouse in the early morning of the 20th of May, the tranquil island of Krakatoa burst into life. Intense pressure building beneath the most northern crater was finally released. Moments later, shock waves were felt in Ketimbang.
What's happening?
There, Captain.
Dear God. Hold this course as best you can.
This initial eruption was witnessed by a dozen ships in the Sunda Strait, including Captain Lindemann on the Governor-General Ludon. Minutes later, the blast was felt 83 miles away in Batavia. When Mrs. van der Stock's china broke, Dr. van der Stock noted the exact time as 10:55 a.m. Initially, he thought he was dealing with an earthquake.
Did you register a tremor? Does that correlate with your instruments?
It's not an earthquake.
I felt a distinct tremor, and the dog...
Forget about your dog show and take a look at this. needle has been moving in a vertical plane. These vibrations are airborne. It's not coming through the ground. It's not an earthquake.
Then volcanic?
I think so.
At last. I've always wanted a volcano. What do we have on the subject?
Among the many instruments used in van der Stok's observatory was a magnetic declinometer, whose floating needles were so sensitive they could detect the tiniest movements in the atmosphere or through the ground. Using the readout from the declinometer, van der Stok realized that the disturbance was in fact an air blast caused by an explosion nearly 100 miles away. But even van der Stok could not have predicted the scale of devastation Krakatoa would wreak. Captain Lindemann witnessed the eruption firsthand. His log forms part of a vital body of information about the eruption.
On the 20th of May at 10:30 in the morning, a volcanic eruption was observed on the island of Krakatoa. We saw from the island a white cumulus cloud rising fast. It rose almost vertically until after about half an hour it had reached 11,000 meters. Here it started to spread like an umbrella as it had reached the height of the westerly winds. Soon, only a small part of blue sky was seen on the horizon.
This initial eruption, however, was only the prelude to a far greater explosion yet to come. Krakatoa had finally woken from its slumber. Volcanologist Mike Rampino is crossing the Sea of Sand, a vast volcanic plain, on his way to one of the most active volcanoes in Indonesia. Mount Bromo has many similarities to Krakatoa. It is fueled by magma generated from the friction of the Indonesian subduction zone, and its crater is approximately the same size as Krakatoa's. But Bromo continuously releases the pressure beneath it and is known to have erupted 50 times in the last 200 years, and so never on the scale of Krakatoa in 1883.
The initial eruption of Krakatoa on May 20th, 1883 was typical for the beginning of an explosive volcanic eruption. There was a sudden explosion and a rise of a column of ash and steam and gas, in this case very rapidly up to a height of about 30,000 feet above sea level. What had happened is a viscous plug of congealed magma and rock was sitting in the throat of that volcano for 200 years. And finally, the pressure below it built up to the point where the rock cap broke. That released the pressure on the magma chamber inside the volcano, and that's like popping the cork on a champagne bottle. In fact, it's like shaking up the champagne bottle first and then popping the cork. This violent eruption was the opening salvo for a series of eruptions that were to take place over the next few months.
As eyewitness reports of the eruption flooded into Batavia, the authorities ordered Willem Bering, the closest government official, to go to Krakatoa and report on the scale of the volcanic explosion.
How dare you burst your way into the office like this? Stand back! Be quiet! Now you tell me what this is about.
Orang Alijeh kermarah.
Stop that nonsense about Orang Alijeh. Your volcano god is a ridiculous superstition. Sekarang, katakan apa yang kamu lihat.
Tanah belah. Air muncrat. Laut mati Krakatoa meleduk. Orang kedua.
I believe you. I've had reports from Batavia and I have orders to go and see Krakatoa Island myself. Saya perlu orang antar saya ke sana. You take me? Who will take me? You take me.
Aing nu nganterkan.
The following morning, Bering and Ajib began their journey to the island of Krakatoa. The volcano that normally dominated the horizon was now invisible, shrouded in clouds of acrid sulfurous gas. Their progress was painfully slow. By 4 o'clock that afternoon, after many hours of waiting, there was still no news of Bering.
Stop. Turn around! Balik, doy!
Although Bering had only ventured within sight of Krakatoa, it was clear to him that the volcano was now a serious threat. On his return, a concerned Bering wired a report of the eruption to Dr. van der Stock at the Magnetic and Meteorological Observatory in Batavia. The Governor-General was immediately informed.
Director, guess what?
You brought my books back.
No, I'm off to Krakatoa. The governor himself has asked me to make a report.
You? He chose you? It should be me who's going. I'm the one who alerted him to the message from Ketimbang.
I expect he thought I was more expendable. You're a married man. No one will miss me.
I shall only be gone a few days.
I can't let young Sherman go alone.
On the 27th of May, 1883, an investigating party of Sherman and van der Stock set foot on Krakatoa. Believing that the volcano was still in eruption, they were surprised to discover that an eerie calm now shrouded the mountain. As they began their ascent up the slopes of the active crater, they saw large areas of the once forested island now lay charred and smoldering.
What could have done this? These trees have been completely flattened by some immense force.
The entire forest has been stripped bare. What do you make of it?
Well, it's as if some superheated whirlwind has torn down the mountain. It's remarkable.
Indeed.
Sherman's report to the Governor-General now provides invaluable evidence of the devastation on the island.
Following in the footsteps of the bravest, or perhaps the most foolhardy, we climbed the bare hills, which did not offer any obstacles other than the loose ash. Horrible was the view of that somber and empty landscape, which portrayed itself as a picture of total destruction. Foul-smelling smoke permeated the landscape, causing us to gag. In addition to the smoke, one also recognized amongst the gaseous products sulfuric acid, which made itself known by its smell.
The samples collected by the expedition are now a vital record of the volcanic material ejected by Krakatoa in the early stages of eruption.
I expect this is what hell looks like.
Should be getting back.
I want to see the crater.
We don't have the time.
I'm going up there.
Sherman, no.
You've become too comfortable stuck in your observatory. Come on. Come. Come on. Not too far now, Doctor.
Not too far. Soon, every sign of vegetation disappeared, and all we could see was the roaring column of smoke. We climbed the last hill, and we were standing at the steep edge of the crater wall.
Who thought hell could be so beautiful?
You really are quite mad, Sherman, aren't you?
Sherman and van der Stock believed that the worst of the eruption was over. Little did they know that in 3 months' time, the entire island of Krakatoa would have blown itself out of existence. Volcanologist Mike Rampino is at the lip of the crater of Mount Bromo in East Java. Bromo's crater is a similar size to the one Sherman would have seen on Krakatoa.
Sherman, in a sense, was one of the first volcanologists. At that time, volcanology was in its infancy, and we didn't know much about the behavior of volcanoes. And in fact, the study of Krakatoa was the first real study of a volcano that began to give us information about how volcanoes work. And Sherman actually did a very valuable thing by collecting samples of the material that had been erupted by the volcano during its earliest stages of eruption. Clearly, when Sherman walked across Krakatoa, he should have known that it was a dangerous place to be.
Sherman's party had no real understanding of just how dangerous their expedition had been. Today, volcanologists like Mike Rampino fully understand the deadly forces that had stripped the slopes of Krakatoa, forces known as pyroclastic flows.
They were quite lucky to be there during a time when the volcano was less active because the area had been devastated by pyroclastic flows and surges, hot mixtures of ash and gas.
Krakatoa's first eruption had thrown fine particles of ash high into the atmosphere, but the real danger lay closer to its flanks. Heavier material had cascaded down the sides of the volcano as superheated debris. Anything standing in the way of this pyroclastic flow would have been incinerated instantly. By the end of May 1883, Krakatoa, the volcano that had violently awoken after 200 years, returned to relative calm. For 3 months after Sherman's expedition, all that was noticed on the island was a continuous plume of smoke and the occasional rumble. In the belief that the eruption was over, life in the coastal communities of West Java and southern Sumatra returned to normal.
It's fairly common during many explosive eruptions, during the early stages, that you get some activity and then things quieten down again. This is the really dangerous thing about explosive eruptions. It's almost impossible to predict when the climax is going to be. In the case of some eruptions, it can come within a week. In the case of Krakatoa, it came months after activity started. And there's a danger always that once activity has died down, people are going to say, well, that's it, let's forget about it, we're all safe now. But that often isn't the case.
Along the coastlines of West Java and southern Sumatra, the morning of Sunday, the 26th of August, 1883, was as any other. But within 24 hours, Krakatoa would destroy itself and devastate the entire area in an eruption of cataclysmic proportions. Destined for southern Sumatra, the Governor-General Ludon prepared to leave on its regular journey across the Sunda Strait.
Is that the paraffin, Mr. De Kuiper?
25 barrels, sir.
Good.
At 6 minutes past 1 on the afternoon of Sunday, the 26th of August, 1883, all 3 craters on the volcanic island of Krakatoa erupted in a massive volley of explosions. The enormous pressure that had been building for hundreds of years was suddenly released. What was to become the most devastating volcanic event in recorded history had begun.